Myself, K.M. Rupnavar from TC College, Baramati. And already in the previous lecture, we have started our paper CHA 5403 and the section 1 syllabus we have already discussed. So see, our paper heading is CHA 5403. Here 4 represents the 4th semester and heading of the paper is Analytical Methods for Analysis of Fertilizers, Detergents, Water and Polymer, Paint and Pigment. This paper is of 48 lectures and 12 tutorials will be there. And the section 1 is which I am going to teach you. The heading of section 1 is Analysis of Fertilizers, Soap and Detergents and Wastewater. And the section is for 24 lectures. So, as already we have seen the syllabus, but I have written the points which included in the chapter number 1. So, Analysis of Fertilizers, this is our chapter number 1. In the analysis of fertilizers, main points are sampling and sample preparation, then total nitrogen, because the fertilizers contains NPK, that means nitrogen, phosphorus and the potassium. So, our first element is nitrogen, and nitrogen is estimated by various methods as Kjheldhal's method, total nitrogen by reduced iron method. Then third method is urea nitrogen method. Next one is the total Kjheldhal nitrogen methods and spectrophotometric method. Then ammonia nitrogen method. So nitrogen is estimated by using these 5 processes. And our next element is phosphorus. Here total phosphorus is determined. Then available and non-available phosphorus can be determined. Then alkalimetric ammonium molybdophosphate method is there to find out amount of a phosphorus quantitatively. Then water soluble phosphates are there and the citrate insoluble phosphates are there. So various methods are there to determine the amount of phosphorus or amount of phosphate. Then our third element is potassium. Potassium is estimated by using the sodium tetraphenyl borate method and the flame photometric estimation, that is FES. So, our first chapter is of 6 lectures and you can refer the reference number 1 which is given in our syllabus. The quantitative analysis of the materials is given in the book of a author F.J. Welcher, and now we are going to see the introduction of fertilizers. So see what is meant by fertilizers. So see, as human being needs a food for their living, so at the same way the plants also need certain amount of micronutrients for their growth, for their living. So, in the same way that human need to eat properly to stay healthy, to stay fit, same way plants also need some amount of the nutrients as a NPK to grow properly. Fertilizer is the substance which is added to the soil to improve plants' growth and the yield. Basically, it is a chemical or natural substance is added to the soil or land to increase its fertility. As you know, the fertilizers are of 2 types, organic fertilizers and the inorganic fertilizers or artificially prepared fertilizers. The organic fertilizers contains the compost fertilizers and so on, and the inorganic fertilizers or the artificial fertilizers, that is urea, Then our other fertilizers which we will buy from the market. These are the artificially prepared fertilizers. So, chemically or naturally prepared substance is added into the soil to increase the fertility. This is called as a fertilizer. And fertilizers are the supplementary foods for the plants and needs around 60 nutrients to be healthy. Then, what is meant by fertilizer exactly? A fertilizer is any material it will be natural or synthetic. That means natural means organic and synthetic means inorganic or artificially prepared fertilizers. And these fertilizers are supplied to soils or to the plant tissues to supply one or more plant nutrients essential to the growth of the plant. So this is the definition of fertilizer. A fertilizer is any material of natural or synthetic origin that is applied to soils or to the plant tissues to supply one or more plant nutrients essential to the growth of the plants. Now, the fertilizers are complete versus incomplete type fertilizers are there. And the complete fertilizers means the fertilizers which provides the all types of nutrients as a nitrogen, phosphorus and potassium to the plants to be healthy the plant. So, see, the complete fertilizer includes all the three types of the macronutrients NPK. For example, some fertilizers contain 10-10-10, that means 10% nitrogen, 10% phosphorus and 10% potash. Same way, another fertilizers written here. This will example of a complete fertilizer. And incomplete fertilizer means what? Some fertilizers have not all the macronutrients are present, but only one or two fertilizers, only one or two the element or macronutrients are present, but not all three. That's why here is the example written 20-0-0 means nitrogen is 20% and remaining all are absent as a potassium and phosphorus. Then in the see this is a next example which is different from this two 12-0-44. So see 12 is a nitrogen percentage, that means 12% nitrogen is there. Then 0, that means phosphorus is absent and the potash. This is a in highest amount 44%, means this one contain only 2 micronutrients and initial two examples contain only 1 macronutrients. That means all 3 at one time not present in the incomplete type of fertilizers. So complete fertilizers contains 3 macronutrients which are basic NPK, and in incomplete fertilizers only 1 or 2 type of macronutrients are present, not all 3. Then there are fertilizers which is nitrogenous fertilizer, potassic fertilizer and phosphoric fertilizer. So nitrogenous fertilizers means what? The fertilizer material which contains nitrogen, this is called as a nitrogenous fertilizer. An example is urea. And they may contain secondary nutrients like calcium and sulfur. Then next example or the next type is a phosphatic fertilizer. Phosphatic fertilizer contains obviously phosphorus, and the phosphorus is expressed in terms of the oxidized form P2O5 in the fertilizers. And in soil and plant, phosphorus is expressed in elemental form. So this is a phosphatic fertilizer, and obviously potassic fertilizer means the potassium is present. Then the type of fertilizer based on concentration of primary plant nutrients as a NPK in the fertilizers, means depending upon the amount of NPK, the fertilizers are shown here First type is low analysis fertilizer and second one is a high analysis fertilizers. So in the low analysis fertilizers contain less than 20% of the primary nutrients NPK, means their concentration is less than 25%. Then example is SSP, which contains 16% P2O5. Then next example of low level fertilizer is sodium nitrate, in which 16% nitrogen is present. So this is a low level fertilizer. That means the fertilizer which contains less than 25% of the micronutrients. Then in the high analysis fertilizers, obviously the primary micronutrients NPK are greater in percentage, greater than 25%. And example is urea. Urea contains 46% nitrogen. Then anhydrous ammonia, which contains 82.2% of nitrogen. And the ammonium phosphate, which contains 20% nitrogen and plus 20% P2O5. By adding both, 40% of the micronutrients are there. So these are the low analysis fertilizers and the high analysis fertilizers. Again I am repeating, low analysis fertilizers contains less amount of the NPK than 25%. And the high analysis fertilizers contains greater amount of fertilizers, micronutrients NPK greater than 25%. Then again there is a classification of the fertilizers based on the physical form. The fertilizers are either in the solid form or in the liquid form. So they are present in the powder form when they are solid, when they are liquid obviously in the liquidy form. So in the solid, this will be either in the form of a crystals. Example of the crystal type of the solid fertilizer is ammonium sulfate. Then the prils, means small balls, urea, diammonium phosphate and superphosphate. These are present in the form of a small balls or the prils. Then granular form is Holland granules. Then super granules, that are urea super granules, and the briquettes form, that are urea briquettes. So main examples are crystalline form is ammonium phosphate, pril form is urea diammonium phosphate and superphosphate, and granular form is Holland granule, super granular form is urea and briquette form is urea briquette. So these are the solid fertilizers. And liquid fertilizers are the fertilizers which are in the form of a liquid, and liquid form fertilizers are applied with irrigation water or for direct application, and its two types are there. First one is a clear liquid fertilizer, when the fertilizer gets dissolved 100% into the water, and second type is suspension liquid fertilizers. That means there is no complete dissolution but suspension is there. Suspended fine particles of the fertilizers are observed in the water. So two types of fertilizers are there. First one is a clearly soluble fertilizers and second one is a suspended solid particles on the water. Then how fertilizers grade will be written? So see, fertilizer grade refers to the minimum percentage of nitrogen in phosphorus P2O5 and potash is present in the form of K2O in the fertilizer material, and the fertilizer analysis expresses weight as a percentage of nitrogen, phosphorus and potassium. Here nitrogen 20%, phosphorus 10% and the potash is 20%. So see here how fertilizer is analyzed. I have written, for example, we have a 100 kg bag of any fertilizer. For example, it will be urea, but urea does not contain phosphorus and potassium. That's why just take a bag which contains all three types of the micronutrients NPK, and bag is of a 100 kg weight, and on the bag the grade is written 15, 5 and 18. 15:5:18. That means 15% is the nitrogen, 5% is the phosphorus and 18% is the potassium. So we have to find out how much weight is of a particular macronutrient. So see, how can you find how much amount of a macronutrient is there? So see, for nitrogen 15% is given, therefore 15 into 100 it will be 15 kg. 15 by 100 into 100. 100 get cancelled, therefore it will be 15. Then phosphorus, it comes 5 kg, and potassium, it's equal to 100 into 18 divided by 100. 100 get cancelled, that's why it will be 18 kg. So 15 kg is the nitrogen, 5 kg is the phosphorus, and 18 kg is the potassium. So in the 100 kg bag, this much amount of the NPKs are present. If bag is of 50 kg, you can find out the weight as 50 into 15 divided by 100. The weight which will come, that will be nitrogen, then phosphorus and the potassium. So by such a way you can write the amount of nitrogen, phosphorus and the potash present in our fertilizer. Then how sampling can be done? Sampling means what? We have to collect a sample or a material in the proper form. So a sampling procedure was developed involving insertion of a double tube trier through the open top of the bulk bag and angling the probe towards the bottom outside extremity of the bag in a specified regular pattern dispersed throughout the bag geometry. So see, we have a large bag and we have to collect a sample. It will be either from the top of the bag, from the middle of the bag and from the bottom of the bag. So for this purpose you have to insert a double tube trier to collect a sample from the top of the bag, from the bottom of the bag, and you can collect sample randomly from the top and the bottom or the middle of the bag, and this sample is collected together, and from this you can convert into the solid form or the powder form, and this remaining material, suppose you have a 1 kg of the sample is there, then around half kg you can convert it into the powder form or grind this fertilizer into the powdered form, and remaining half kg you can store into the airtight box or a bottle for the further use. This is called as a sampling, and sampling can be done in the less than 50 kg bag. This is a basic, but if the large scale sampling you have to perform in the industry, then you can take at least 10 bags and select sample or collect sample from the top of each bag, from the bottom of each bag, and then mix the sample from all the 10 bags which you have collected from top and the bottom together, and then you can use this sample for the analysis of amount of nitrogen, phosphorus and the potash. So the sampling can be done for various purposes. Here I have written. So size of the particle, then the quality of the fertilizer, homogeneity of the particles is important. Then a sample must be of a sufficient mass or volume for the required analysis, means the sample which we are going to collect from top of the bag and the bottom of the bag, this sample will be in the sufficient mass or in the sufficient quantity, as we are going to find out the NPK from this sample. So minimum requirement will be the sampling of any 10 bags in a lot or shipment. So this is the sampling. Then our first point is the nitrogen estimation, and the nitrogen from the fertilizers is estimated by using different methods as I have discussed earlier. At least 5 methods are given in our syllabus, and the first method is the Kjheldhal's method. And the Danish chemist John Kjheldhal in 1849 to 1900. This is his lifetime, and in 1883 he found a method for determination of a nitrogen in organic substances, and this one is the photo of a chemist John Kjheldhal. And satisfactory method he has developed for finding nitrogen level as low as 1 milligram per liter. So, this method involves 3 main steps: digestion, distillation and the titration. Then this one is the diagram. So, see in this first diagram or in this first image, here is the benzene burner, this one is a tripod stand, and this is a Kjheldhal flask which is attached to a stand. So, in the Kjheldhal flask, our fertilizer material is taken, which we have collected from the bags by sampling method. Then this substance plus concentrated H2SO4 is added into it, plus copper sulfate plus K2SO4 is added into it, and we have to digest this sample initially. First step is digestion. Then this digested sample is collected in this second flask, and the capacity of this flask is around 1 liter. This is a round bottom flask, and this round bottom flask contains the Kjheldhal solution which is obtained after digestion. This solution is taken into this flask, and now we have to add the NaOH solution into it. Then there is a Kjheldhal tap. Through the Kjheldhal tap, the vapor comes out, and here is the condenser. Vapors get cooled down, and the liquidy form of a standard acid will be collected in the pure form, and then you have to titrate this. So, this is a basic diagram of a Kjheldhal method. Then this is the slide which shows a definition which is already I have told: a substance which supplies to the soil the constituents which are required for healthy growth of the plants. And as we have already discussed, the fertilizers are natural, artificial and the mixed fertilizers, and main point is the nitrogen, phosphorus and the potash. So, we are going to find out the amount of nitrogen from the Kjheldhal method. So, here is the Kjheldhal method, and we have seen the diagram of it already. So, this method is used for analysis of the fertilizers which contain mainly nitrogen in the organic and the ammonical forms. So, for this method, the reagents are given here. First one is the sulfuric acid, H2SO4. Concentration is in between 95 to 98% pure. Then sulfuric acid which is prepared 0.5 normal, NaOH is a 0.5 normal. Then mercurous oxide or the metallic mercury is taken. Then potassium sulfate is required, sulfite or thiosulfate solution. Then zinc granules, and indicator is required, methyl red or methyl blue. So these are the chemicals or the reagents which are useful for the nitrogen estimation by using Kjheldhal method. So see, here is the procedure. Initially you have to transfer the sample containing 200 to 600 milligram of nitrogen to 800 ml Kjheldhal flask, as I have shown here in the diagram. Here we have to transfer initially substance or the fertilizer into the Kjheldhal flask, and the substance is 200 to 600 milligram. Then we have to add 0.7 gram of mercuric oxide or 0.65 gram of metallic mercury, and 15 gram potassium sulfate and 25 ml of sulfuric acid. If required, add further 10 ml of additional H2SO4. If our substance is not soluble, then you have to add the more amount of the H2SO4, about 10 ml into it. Then place the flask in an inclined position on heater for 5 minutes. As I have shown in this diagram, such a way inclined position is this. You have to put the flask in an inclined position on a stand and we have to supply a heat. And heat is provided for 5 minutes only. Then if flooding is excessive, add small piece of porcelain. That means when bumping of the solution occurs, then you have to add a porcelain piece into this Kjheldhal flask and continue heating at the recommended time and until solution becomes clear, and continue digesting for 30 minutes. Means what? Initially we have to take a Kjheldhal flask, add around 200 to 6 milligram of the fertilizer into it. Then we have to add 0.7 gram of mercuric oxide, then add 15 gram of potassium sulfate, then add 25 ml of sulfuric acid. If required, then add again 10 ml of the sulfuric acid into it. Then heat the solution for 5 minutes, and heating is done, still the solution will become clear, and the digestion time is at least 30 minutes. If the organic material is present, then digest the solution for about 2 hours. Means organic material does not digest in 30 minutes, that's why we have to digest this for at least 2 hours. If necessary, then add further more H2SO4, then cool the solution and add 250 ml of the water on a cool, and you have to cool this solution at 25 degrees Celsius. Then heat the solution at a recommended rate and add some zinc granules or few glass to avoid bumping. Then add 25 ml sulfite or thiosulfate to precipitate mercury. Shake flask for further precipitation. Add 50 ml of NMS solution from the side of the flask. Then immediately connect the flask to the distillation apparatus in such a way that tip of condenser just dips into 50 ml of 0.5 normal H2SO4 in Erlenmeyer flask. Shake the Kjheldhal flask to mix the content and then boil the solution. Distill the solution and collect 250 ml of distillate. 45 minute time is there, and add 5 drop of methyl red or methylene blue indicator to the distillate and titrate the solution with 0.5 normal alkali, that is sodium hydroxide. And end point of the titration is faint green. Carry out back and blind titration, and the calculation is done as percentage of nitrogen is equal to ml of H2SO4 into normality into 1.008 divided by weight of sample in gram. So this is the Kjheldhal method. So see, we will see again procedure repeatedly. Initially we have to take around 200 to 600 milligram of the nitrogen or the fertilizer in a Kjheldhal flask. Then add 0.7 gram of mercuric oxide or the 0.65 gram of metallic mercury. Then add 15 gram of the potassium sulfate and 25 ml of sulfuric acid. If needed, extra addition is there around 10 ml. Then keep the flask in the inclined position on a heater for 5 minutes. Heat gently, bumping is there. Then we have to add porcelain pieces into the flask and you have to heat the flask up to the solution become clear, and for the organic substances we have to heat the solution up to 2 hours or digest the solution for at least 2 hours, and when again there is no digestion occur or the clear solution is not obtained, then add excess amount of the H2SO4 if necessary. Then cool the solution at 25 degree Celsius, and if bumping is there, again add few glass or granules of zinc to avoid bumping. Then add 25 ml of, after cooling add 25 ml of the sulfide solution or the thiosulfate solution for precipitation of mercury. Then shake the flask further for further precipitation. Again add 50 ml of NaOH from the side of the flask. Now immediately connect this flask to the distillation apparatus in such a way that tip of the condenser just dips into the solution of the 50 ml 0.5 normal H2SO4 in the Erlenmeyer flask. And shake the Kjheldhal flask to mix the content, and then boil the solution, distill the solution and collect 20 to 50 ml of distillate, and time required for this process is 45 minutes. Add around 5 drops of the methyl red or the methyl blue indicator into the distillate and titrate the solution with 0.5 normal alkali NaOH. End point is faint green. Same way you have to carry the back and blank titration, and calculation can be done by the formula percentage of nitrogen is equal to net ml of H2SO4 into normality into 1.008 divided by weight of sample in gram. Weight of sample which we have taken initially, then net ml of H2SO4 we have initially taken around 50 ml of the H2SO4 into the conical flask, and normality of H2SO4 is 0.5 normal. So by using this you have to calculate percentage of nitrogen present in our fertilizer. So this is the Kjheldhal method.